Hello everyone. Last class I just discussed about the zone plate and two types of zone plates like positive zone plate and negative zone plate. Positive zone plate means it will only odd zones will be transparent and even zones will be opaque. Whereas in negative negative zone plate means you will have odd zones will be opaque and even zones will be transparent. Okay, and why we are going for particularly odd zones and positive zone plate and even zone plate means what is the main difference between uh, is like if you take a zone plate, all the off period zones are transparent, then you will get a intensity is almost like a square. I is equal to a square intensity at any point due to the uh, intensity at any point p due to the complete planar wavefront if all the off period zones are transparent, then you will get only intensity a square. If you take positive zone plate or negative zone plate, the intensity will be almost like 400 times to the intensity what you are getting here. That's why these zone plates are to get more intensity at point P. Okay. So now today's class we will discuss about the construction and working of zone plate, and also we derive the formula for its focal length. Okay, so how do we construct the zone plate and how does it works? Okay, zone plate is nothing but it's a specially constructed diffraction scheme. Okay, it's just like a transparent glass plate which works on the diffraction phenomena such that light from every alternate zone is cut off. Like if you take positive zone plate, only light from odd off period zones only transparent, other even off period zones are blocked, so no light will come from the even zones. Whereas if you take the negative zone plate, you will only get the light from the even zones. Light from the odd zones will be cut off. So that is the point here is mentioning. Light from every alternate zone is cut off. Okay, and it's a transparent glass plate which works on the diffraction phenomena, and the light from every alternate zone will be cut off. How do we construct a zone plate? To construct zone plate, what we have to do is take a white paper and draw a concentric circles such that each circle having the radii proportional to the square root of the natural number. Like if you are drawing a first circle, the radii must be proportional to the square root of 1. If you are drawing second circle, radii must be proportional to the square root of 2. So like that, all concentric circles must be proportional to the square root of natural numbers. Then what you have to do is odd number zones like first, third, fifth, seventh, ninth, all the zones you cover with a black ink and take a reduced photograph. Then this looks like this one, figure B. So here the first zone is covered with the black ink, and second zone is left transparent, third zone is covered with the black, and fifth zone is covered with the black. So this is the on white paper you have darken and take the reduced photograph. The negative of this photograph will be look like this one. Okay, so this is on white paper you will make and take a photograph. That negative will look like odd zones. First zone, third zone, fifth zone will be transparent. Here it is a block, but in negative they look like a transparent. Okay, such plate, if that such plate is this negative is incident to the beam of light. Okay, so you kept this plate and you incident a light perpendicular to that one. So if there is light incident on this one and this plate is perpendicular and screen is placed at the other side, this is the screen. Okay, right, you will get the image, the observed that the maximum brightness at point P, you will see some brightness. Okay, so here you can see clearly. So point P is there. This is the XY is the upper half of the incident plane wavefront. Okay, we are only considering the only upper portion. P is the point at which light intensity is to be considered due to the this off period zones. So this distance of the point P from the wavefront is B. Okay, so this is a wavefront X. Okay, in this OM1 is the first off period zone, OM2 is the second off period zone, OM3 is the this is O. Okay, OM3 is the third off period zone, and the distance between P and O is B. Okay, and I already told you the from first off period zone to the point P, B plus lambda by 2, and distance between P and second off period zone M2, B plus 2 lambda by 2. Similarly, M3 also you can get B plus 3 lambda by 2. Okay, so OM1 is the radius of the first period zone, OM1. OM2, this distance, is the radius of the second off period zone. OM3 is the radius of the third off period zone. I already discussed you radius how to find. So radius of the first off period zone R1 is equal to root B lambda. Second off period zone is root 2 B lambda. For nth off period zone, radius will be square root of n B lambda. Okay. From this equation, you can also write B as Rn square by n lambda. Okay, so this B is the distance from the zone plate to the point B. This is also, we can also call it as focal length. Okay, F, focal length. Okay, because of this zone plate and point P, almost light will get focused at point P. So this distance will be almost like a focal length. Okay, as nothing but B. So focal length formula is nothing but Rn square by n lambda. If the source is at a large distance from the zone plate, a bright spot will be obtained at point P. So if source is at very far distance, like almost like a parallel rays are coming, source is at infinite distance means the light will get focused at point P. That is what he is discussing here. So point B. As the distance of the source is large, incident wavefront can be taken as plane 1 with respect to the small area of the zone plot. This is plane wavefront. Okay. The even numbered zones cut off the light and hence the resultant amplitude. Since we are using here odd positive zone plate, okay, so even zones will be blocked. So only transparent portion will be odd number zones. So resultant amplitude will be odd number zones light. So P is equal to that is at point P, resultant amplitude is A is equal to M1 plus M2 plus M3 plus etc. Here it is not M2, it will be M3 plus M5 plus M7. Okay, sorry for the mistake. So since we are using a odd positive zone plate, so only positive terms will be there. That is M1 plus M3 plus M5. Okay, M5 plus M7. Even number zones will be cut off. There will be no light from the even zones. So only you will see odd number zones. So as I told you, the distance B is also called as focal length. Okay, Rn square by n lambda. So from this equation, focal length is inversely proportional to the wavelength. So zone plate has different focal lengths for different wavelengths. If the lambda 1, lambda 2, lambda 3, different lambdas are there, there will be different focal points for the different wavelengths of the radius. Similarly, the radius of the nth zone increases with increasing of lambda. Lambda, if you are keep on increasing, since r is equal to square root of n b lambda, wavelength, if you are increasing, radius of the nth zone also increases. It is very interesting to note that as the even numbered zones are opaque, the intensity at point P is much greater. As I told you, always the positive zone plate or negative zone plate you take. In this case, we are taking positive zone plate. The intensity at point P will be greater than as compared to the whole wavelength is exposed to the point P. I told you intensity is equal to A square due to the whole wavelength, whereas if it is only due to the positive plate, 400 times of the intensity you are getting. So last previous section I have discussed. Okay, so if you expose the zone plate with the white light, what happens? White light will have a different colors of the light. So different colors come to focus at different points along the line OP. So thus function of zone plate is similar to that of convex lens, and a formula connecting the distance of the object and image points can be obtained for a zone plate also. Okay, it almost works like a convex lens. A parallel beam will be converged at point P due to the convex lens. So here, how does the zone plate works? We'll discuss about the working of the zone plate. Let's take this XY. XY is the zone plate, okay, which is perpendicular to the plane of the paper. And S is the point source of the light, and P is the position of the screen for a bright image. I'll use this marker. Okay, so this is the source of light, where light is coming from the source, and this is zone plate, which are having, like, this is point O, center, M1, M2, M3, M4, M5 up to Mn. Okay, first half period zone, second half period zone, third half period zone, fourth half period zone, like that up to n half period zones are there. Okay, similarly downside also same thing. Okay, so light is coming from the source, and when it instant on the first half period zone, due to the diffraction, the light will get focused on point P on the screen. Screen is there, which is at a distance P from the zone plate, and source is at a distance A from the zone plate. Here OM1, okay, which is nothing but radius of the first half period zone. Similarly OM2, which is the radius of the second half period zone. OM3, radius of the third half period zone. OM4 up to OMN, the radius of the nth half period zones. As we know that there is a path difference of lambda by 2 between any two consecutive zones. If you take first half period zone and second half period zone, there will be a path difference always lambda by 2. Similarly, you take second half period zone or third half period zone, there will be a path difference of lambda by 2. This is the basic idea of the half period zones. Okay. So you take SO plus OP. What happens? SO is nothing but A, OP is nothing but B. So SO plus OP will be AB. Okay. Similarly, I want to find SM and SM1 plus M1P. So SM1 I will take approximately A, and this we know B plus lambda by 2. So I already told you distance from M1 to P, B by lambda by 2 for first half period. Second half period then B plus 2 lambda by 2. Okay. So you just add A plus B plus lambda by 2 for first half period zone. If I want to find SM2 plus M2P, SM2 I will take just as it is as A, okay, plus B plus 2 lambda by 2. Okay, A plus B plus 2 lambda by 2. Similarly, if I want to find Smn plus Mnp, what will happen? A plus, okay, this last term will be B plus n lambda by 2. So just add A plus B plus n lambda by 2. So you will see here for nth half period zone, Smn plus Mnp, equal to a plus b n lambda by 2. Now in this equation I want to find what is SMN and what is MNP. Okay, so how do we find? Using the right angle triangles. Okay, you consider SMNO. SMNO, I will use this. Okay, okay, so SMNO is the right angle triangle. Okay, I know this distance, which is A. Okay, and also I will know this is Rn, because radius of the nth of period zone. O to Mn is nothing but radius of nth of period zone. Now I want to find this one, hypotenuse. You know, hypotenuse square equal to Smn square equal to Rn square plus A square. Okay, so you take it out A square as common. Okay, what happens? 1 plus Rn square by A square. Okay, 1 plus Rn square by A square common is there. You take it outside, you will get 1 plus Rn square by A square. So you this Smn will be, it will be under root of, okay, square root of A square. So you will get A into 1 plus Rn square by A square whole power of, okay, you see this is 1 plus x whole power n. How do you write binomial expansion? 1 plus nx. Okay, so higher terms you can neglect. So directly writing it will become as a plus, okay, or yeah, a plus Rn square by 2 2a square ikkada 2a square, right? So a will be, a get cancelled ikkada, so Rn square by 2a, or you keep it a outside, 1 plus Rn square by 2a square. Okay, so the same thing I have done here. If you see the steps, uh, if you see these steps, say Smn will be a into 1 plus Rn square by 2a square. Similarly, I have found Smn here. Now I want to find MNP. Okay, MNP, for that one again we will follow the same steps. Instead of this one, this time it will be MNOP. Okay, it will be MNOP right angle triangle. Last time we have considered this right angle triangle. Okay, now this time this right angle triangle we consider and find out MNP distance. Okay, this is again Rn. Okay, this is B. Same steps as we have done for the previous one. So I will directly write as MNP as B plus, okay, instead of here A you will get a B plus Rn square by 2b. Okay, so we got Smn and MNP. So substitute these values in the equation 1, which is nothing but this equation. So it will be like this: a plus Rn square by 2a plus b plus Rn square by 2b equal to a plus b plus n lambda. A will be cancelled, b will cancel, you will get Rn square by 2. Okay, common this there, 1 by a plus 1 by b equal to n lambda by 2. 2 will get cancelled, so you will get Rn square as n lambda ab by a plus b. Rn will be under root n lambda ab by a plus b. Okay, so here also radius of the nth of period zone is directly proportional to the root n. Okay, so we earlier they asked the focal length formula. The focal length formula is up to this one. You can write up to this one. If they ask that derive the focal length formula, you can use these steps. Okay, now what is the main difference between the zone plate and convex lens? Almost they work like they are used to focus the light, right? So convex lens having only one focal length, whereas Zone plate will have a different focal length. That is the first difference. And also one more thing, convex lens works on the principle refraction, whereas zone plate works on the principle of diffraction. Okay, so you can there are 7 points here. You can write four of them, anything. A zone plate acts simultaneously as a convex lens. A zone plate can act as a convex lens and also a convex lens, concave lens. But whereas it, in addition to the real image, a virtual image is also formed in the zone plate, whereas convex lens always form a real image. Okay, both zone plate and convex lens forms real image of the object. That is the first point. Second point is focal length of the both lenses, zone plate and convex lens, depend on the wavelength. Hence, they suffer also chromatic aberration. Chromatic means color. Color aberration means some problem with the lens. Color chromatic means color. Chromatic aberrations zone plate is much more severe than in the convex lens. Convex lens తో కంపేర్ చేస్తే జోన్ ప్లేట్ లో chromatic aberrations ఎక్కువ ఉంటాయి. Okay. In case of zone plate, the image is formed by a diffraction phenomena. This is the main point. In case of convex lens, the image is formed by the refraction of the light. Zone plate has got multiple focal lengths on either side of the zone plate. Hence, the intensity of the image formed will be much less. Convex lens has only one focus. So, as all the light is focused at one point, the intensity of the image will be more. And another point is, in zone plate, waves reaching the image point through any two alternate zones differ in phase length lambda and in phase 2 pi. In concave convex lens, all the rays reaching the image, the point have zero path or zero path difference. Okay. A zone plate can be used over a wide range of wavelengths from the microwaves to X-rays, whereas glass lens cannot be used beyond the visible region. So these are main seven fundamental differences between the convex lens and zone plate. So please go through that. Any doubts, you can please comment. Please drop a question in the comment section. Okay. Thank you very much.